Now we proceed to calibrate the system. For this we start a script clicking on the red icon in the taskbar. The window shows up. I will move it a little so you can share it with me. We're provided with 4 options and we choose the first to perform an intrinsic stereo calibration. This does pretty much everything in one fell swoop. So I enter 1. This brings up the GUI as before. And 4 windows, of which I choose first the chessboard image 0. Move that into the visible field of view for you to see. Blow it up a little, like so. Do the same with the chessboard image 1. This corresponds to a live view of the scene where we want to perform the calibration, plus some highlighting. I start off by clicking on the calibrate button. You now see this live view. There's a counter running here. We've defined to run up to 20 images which you want to acquire. We're stuck with the first image because the system is waiting to see the calibration plate. So I'll hold that into the field of view of both cameras, and you can hear a beep which indicates that the pattern has been recognized. I now try to move along the whole field of view of both cameras, exploring the entire 3D tracking volume. I also go to the middle. Importantly, I also approach the cameras. There's not much point in keeping the pattern in the same place because the data are not going to be helpful. We're already done with this. We've acquired 20 images. The next thing to do is to close Trackit, which we can do by clicking on the cancel button, bottom right. So I do this, and then the window will provide some information about the tracking quality. So here we get values below 0.2, which is very good. These are the calibration reprojection errors of both cameras, and a third parameter called stereo calibration reprojection error. This also wants to be fairly low, and these are very good values. So we accept the calibration by entering Y for yes or just hitting the return button. Then these values are stored and we can proceed with the measurement steps.